Good day, everyone. Here is another video about different strategies in solving word problems. In this video, I will discuss and give steps on how to solve word problems using a strategy. Look for a pattern. So our first step is to understand the problem. Second, construct a table. Third, find a pattern. Fourth, make a conjecture or prediction. And then the fifth step is to check the answer. So let's have the first step, that is, understand the problem. What is the problem all about? So let's try to consider here an example. So here, John decided to prepare for a marathon by running 10 minutes a day, 5 days a week. Each week, he increases his time running by 1 minute per day. How many minutes will he run in week 9? Now, the problem here talks about the time in minutes John will run in week 9. If he runs 10 minutes a day and 5 days every week, then each week, the time of running increases by 1 minute per day. Now, to understand the problem better, let me have this process. In week 1, so he runs 5 days a week. So we have day 1, day 2, up to day 5. And in the given, in day 1, he runs 10 minutes. So the same in day 2, he also runs 10 minutes. So up to day 5. And a total of minutes John runs in week 1 is 50 minutes because in every week he runs 5 days, so 5 days a week. Hence, because each day he runs 10 minutes, so 10 times 5 is equal to 50. So 50 minutes. He runs 50 minutes every week. And then in week 2, notice here in the given that each week he increases his time running by 1 minute per day. So in week 2, for day 1, he runs 11 minutes. In day 2, he runs 11 minutes also up to day 5. So in week 2, he runs a total of 55 minutes, or we can add this one, or we can just multiply 11 times 5. It becomes 55 minutes in week 2. So in this step, we can also ask, what do we need to find out? So in this problem, we are to find the time in minutes that John will run in week 9. So another one here, we are going to determine the number of variables. Here, are there 1, 2, or 3 or more variables? So in this problem, we have minutes per day is our first variable, and then minutes per week is our second variable. So in this problem, we only have here 2 variables to consider. So now let's proceed to our step number 2, or the second step, which is to construct a table. Now, setting up a table and filling in the information given in the problem is a great way to organize things and provide a visual so that the rule of the pattern can be determined, where it shows the relationship between numbers, Another is we can decide for the number of columns needed based on the number of variables. Now notice here, from our first step, we have, in this problem rather, we have found out that we will be using two variables here. Hence, it will correspond to the number of columns in our table. So here, because we do have two variables, so we need two columns. So first column, we have here for the minutes per day. So we have this first column. And then for our second column, for our next variable, we have here minutes per week. However, we can also add another column for ease of our, interpretation of the problem. So we can add this column for the week number. So because we are to find the time in minutes that John will run in week 9, so we can have here week 1, week 2, week 3, up to week 9 in our table, so that we will know how many rows do we need in our table. So that's it. Now let's go back to the problem. Here in week 1, so notice here in week 1, and every week he runs 5 days. So we have here day 1, day 2, up to day 5. And in week 1, every day he runs 10 minutes. So we can write here in the minutes per day column, week 1, we have 10. It means 10 minutes per day. And then for the total here, the minutes per week is 50 minutes. So we can enter here in our table in the last column, 50. Now, in week 2, so again, for week 2 here, we do have 5 days. 5 days here. So in each day, John runs 11 minutes. So we can have an entry here, 11 in the second column for week 2. And then for the number of minutes in week 2, we have here 55 minutes. So we can just enter here in our table 55. So that's it. Now let's proceed to our third step, which is to find a pattern. Now, a pattern can be defined as a repeated occurrence or as something that follows a specific rule. We can determine the relationship between the numbers. So like find the difference between two consecutive numbers, decide whether the numbers have been multiplied or divided by any given number. Or we can also find out if they are rising or falling numbers that increase or decrease following a regular sequence, or any relationships that you can observe. Now, these three here, these three are the most common way to check if there is a pattern. So let's go back to our table here. So if you're going to continue here, we can have an entries for week 3, so that we can really determine the relationship between the numbers, or we can find a pattern out from these entries. So in week 3, again, notice that in the problem or in the given here, each week he increases, or each week John increases his time running by 1 minute per day. So notice that each week, so during the 5 days, because he runs 5 days a week. So each day there, it increases 1 minute. Okay, hence, in our next entry here, From week to 11, in week 3, it becomes 12. Follow? And then we can multiply this by 5. Or we can just add 12 plus 12 plus 12 for 5 days. Or simply we can multiply it by 5. Then we have the minutes per week or minutes in week 3. We have 60 minutes. Follow? Now here, as you observe here in the table, so we can multiply. We can multiply 5 to the minutes per day. That's why we have 50 here. 5, we have 55. Or we can just observe here in the last column. Now, take note here that the numbers here are increasing. Follow? So we have used this pattern or observation. So it is increasing and it increases by 5. As you can see here, 50 plus 5 is 55. 55 plus 5 is 60. So in this case, we have found out our pattern. Follow? That we just add 5 in the previous entry to get the next entry in our table. Now let's proceed to the fourth step, which is make a conjecture or prediction. Now, when a pattern is established, it is easy to predict what comes next. What do the numbers have in common? It's also important to consider whether or not the pattern will continue predictably. Because in some instances, the pattern may look one way for the first few entries, then change. So this is important to consider as the problems get more challenging. But here in our problem, the pattern will continue predictably. So as you noticed from our previous step, we just add 5 from the previous entry, say 50, you add 5, you get 55 for the next entry. So here plus 5, you get 60. Then we can easily to predict what comes next. So if we add here 5, we have 65. So add 5, we have 70, 75, 80, 85, and then 90. So notice here, we have arrived at 90 minutes in week 9. So let's proceed. Let's have here step number 5, our last step. That is check the answer. So to check the answer, we can check it if the pattern fits in every step in the sequence. So here, notice that in the given problem, each week, John rather increases his time running by 1 minute per day. So from week 3, we have here each day, John runs 12 minutes. Hence, in week 4, John runs 13 minutes, right? So, followed by 14, 15, 16, 17, and 18 minutes per day in week 9. So we can check our answer. We can multiply because we know previously that to get the minutes per week, given the minutes per day, we just multiply this one by 5, right? Because John runs 5 days per week. Follow? So we have 50, this 11 times 5, we have 55. So to check our answer, we can multiply 18 by 5. So of course, 18 times 5 is 90. Yes? we have checked our answer. So we can now conclude. And we can say that John will run 90 minutes in week 9. Okay? So let's have the next example. Okay. So here is the given in our next example. Miriam plants 3 seeds for every 8 seeds that her mother plants. Now the question is, how many seeds has Miriam planted when her mother has planted 64 seeds? So let's have first the first step, which is to understand the problem. Now in this example, Miriam and her mother are planting seeds. Now for every 3 seeds Miriam plants, her mother, so we have here, so again, for every 3 seeds Miriam plants, her mother plants 8 seeds. Now, if her mother has planted 64 seeds, then the question is, how many seeds has Miriam planted? Now, in this problem, there are how many variables do we need to consider? So we have here Miriam's seeds and mother's seeds. Hence, in this problem, we will consider 2 variables here. It means in our table, for our second step, we will be considering 2 columns. 2 columns only. For Miriam's seeds and then for mother's seeds. So let's have step number 2. So let us place the entries in our table based from the given problem. So first, Miriam's seeds, 3. It means Miriam plants 3 seeds and her mother can plant 8 seeds. Next of 3 is 6, right? So for her mother can plant 16 because for every 3 of Miriam, her mother can plant 8 seeds. So this becomes, if Miriam can plant 6 seeds, so for her mother, she can plant 16 seeds. Follow? So if we are going to continue, if we have here 9, then for her mother, we have 24. So the problem now is, how many seeds we have here has Miriam planted when her mother has planted 64 seeds? So to answer this problem, we will be looking at the pattern. Let's proceed to our third step, that is to find a pattern. Now, based from the entries in our table here, the pattern here is evident. Why? Since Miriam's seeds are increasing in multiples of 3, as you observed here. So first, we have first entry here, we have 3, followed by 6, 9. So as you can see here in the first column, the entries here are multiples of 3. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. Or we can just add 3 from our previous entry to get the number or the entry, or to get the next entry rather. So 3 plus 3 is 6. If we add here 3, we get 9. Follow? And also in the second column, for her mother, her mother's seeds increase in multiples of 8. As you can see here, we have 8, 16, 24. Or we can just add 8 from our previous entry, that is 8, to get the next entry, that is 16. And then we just add 8 here from 16 to get 24. So hence here, we have observed pattern. Now let's proceed to our fourth step, that is make a conjecture or prediction. So we will be continuing the entries on our table. So based from our found pattern. So here we will just add 8 from 24. So we get here 32. Next, we add 8, we get 40. Next entry is 48. And then the next is 56. Next to 56 is, of course, 64. So now here, we are to find this entry here. So since we know that this column here, the entries here are multiples of 3, or we just add 3 from the previous entry to get the next entry. So we add here 3, we get 12. Okay, we add 3 from 12, we get 15. Next entry is 18. Next is 21. And we have here 24. So here, in our fourth step, we have found out that when her mother plants 64 seeds, Miriam plants 24 seeds. But take note that we cannot make our conclusion directly. We need to have our last step, which is to check the answer. Now we will be checking each entry here. So based from our observed pattern. So you will check whether if each entry here is correct. Follow? Or another way is from our previous step, step 4, we can make a conjecture instead of a prediction. Because we have made a prediction here, wherein to get the next entry, we get the next entry based from our pattern, observed pattern. So based from our observed pattern also, we can make a conjecture that if X is equal to Miriam's seeds divided by 3, then her mother's seeds is equal to 8 times X. So how to do it? So let's have here. Okay, based from our conjecture here, so that we can check our answer. Another way of checking is by using conjecture from our previous step. So if we have here, okay, let's try to use our conjecture to check our entry. So we have here from our conjecture, we can divide Miriam's seeds by 3. So 3 divided by 3, we have here this one. 3 divided by 3 is 1. So for her mother's seeds, we have 8 times X. So we multiply 8. We multiply 8 by X. We have 1. So this is 8. So as you can see, we have here the entry 8. Another one here. Again, for X, we have Miriam's seeds. So Miriam says we have 6 divided by 3 is 2. So this is our x here. This is our x. So then for her mother's seeds, we have 8x. We can multiply 8 by x. So we have 8 times 2 is 16. As you can see, we have here 16. So another one here, we have 9 divided by 3. This is using our conjecture, is 3. So 8 times 3 is equal to 24. So to check, we can use our conjecture. So we have here 24 divided by 3 is 8. Then 8 times 8, we have 8x is equal to 64. So it means that the entries in our table are correct. Hence, we can say that when Miriam's mother has planted 64 seeds, Miriam has planted 24. So this is our conclusion. Actually, there are many ways to check your answer. So you can check by using our conjecture, or you can check using our observed patterns wherein you can check all the entries here in the first column as well as the entries in the second columns, because we know, we have found out that in our first column, the entries here are multiples of 3. So you can check each entry. Then for our second column, all the entries here are multiples of 8. So you can do it also. So not by using this conjecture. So I just showed this one for other way, other option. So we are done. Thank you so much for watching. I hope you have learned something. That's all for now. God bless and keep safe always. Bye.